Hello students, and welcome to this video on Chapter 15, Forecasting. We're going to learn a couple forecasting techniques and learn how to evaluate the effectiveness of forecasting techniques. So forecasting techniques, as it says there, is there's a variety of methods. We can look at the short range, given 1 or 2 months, medium range, and long range where it's more than 1 or 2 years. So there's different forecasting methods that are better suited for different time frames. We're going to look at the short range in this video for this chapter material. Short range, where we're going to look at forecasting for 1 or 2 months. A couple terms that we should be aware of in here, where we have a trend, long-term movement of the item being forecast, and that's something that we can see when we draw a graph of the data. We can see if there's any trend in that, and that then helps us determine the appropriate forecasting method. We may see some random variations, movements that are not predictable, follow no pattern, or more of a cycle or seasonal pattern in there where there's movement in the forecast, in the demand, but occurs periodically in a short run and occurs at regular intervals. So the forecasting methods that we're going to learn about in this chapter is we're going to focus on the time series techniques using historical data to predict future behavior, whereas regression methods, we would learn in other course material. So time series methods that make use of historical data collected over a long period of time. We look at the past data or the historical data. We develop a forecasting method, and we can compare what we would have predicted in the past versus the historical data to see how accurate our forecasting method is. If it's accurate, then we have more confidence in using that method to predict future events. Forecast methods are based only on one factor, which is time. The first forecasting method we're going to learn about is the moving average. So moving average uses values from the recent past to develop the forecast. Useful for forecasting relatively stable items that do not display any trend or seasonal pattern. It's a method that basically it's called the moving average because we're taking the average of a certain number of past data, and as we go through the time period, our average is going to be moving. We can take a look at an example. In this slide, we're going to go into Excel here, but this is a paper clip supply company wants to forecast orders for the month of November using the first 10 months of data. We're going to develop a 3-month and a 5-month moving average using that data. So let's go into Excel, where we have this data here. And we're going to develop a 3-month moving average. Let's just put that here. Moving average 3 months, and then a moving average 5 months as well. So a 3-month moving average is we look at the 3 months prior to it, and we use these numbers to forecast the demand in the next time period. So a 3-month moving average, we're taking the average of the last 3 months, and that's what we would predict. And it's a moving average, so we can just copy this down. As we copy this down, let's get rid of all that nice stuff there. Let's make it to 1 decimal place. There it is, our 3-month moving average. So 103.3 is the average of the 3 previous, 88.3 is the average of the next 3 of the 3 previous to the month of April. So the November forecast of 110 is the average of August, September, and October. So a 5-month moving average, we're going to look at the first of the preceding 5 months. So we'd have 3, 4, 5. So we're going to predict or forecast a value for June based on the last 5 months of data we have. So of course, in a 5-month moving average, we have fewer forecasts, but we can copy this down. Let's get rid of all that. Let's make it on decimal place, nice and centered. So there's our forecast. A 3-month moving average is going to forecast 110 orders delivered for November, whereas a 5-month moving average is going to deliver 91 items. So two different forecasting method, or same forecasting method, two different time periods built into the moving average in terms of how many preceding units we're taking into consideration. So the question is, which one is correct? Well, we'll learn about that later on in our chapter. Let's take a look back at our PowerPoint. So this is a moving average concept. Let's go back to our material here. Oops, not that. So this is what we've done. There's a number. So it's just some elements of the moving average. A longer period moving average, like the 5-month, reacts more slowly to changes in demand than do the shorter period moving averages. The appropriate number of periods to use often requires trial and error. So we did 2, and we're going to see later on which one is going to be preferred. As it says there, it's good for short-term forecasting. We're going to be using this generally for predicting or forecasting one extra time period. So the other type of forecasting that we do is called an exponential smoothing. Basically, in this method, it assigns a value alpha to the most current data. So it's going to be one that's going to be weighted more so in the more current time period, and then less of a weight in the older values. So this is the formula we're going to use. So F sub t plus 1, that's going to be the forecast for the next period. So we're forecasting the next period. We're going to look at a value called alpha. It's a weighting factor, or called a smoothing constant, times last month's or last time period's demand, plus 1 minus alpha, times the last month's or last time period's forecast. So the decision we have to make here is, what value do we assign the smoothing constant? So the most commonly used values of the smoothing constant are between 10% and 50%, 0.1 and 0.5. Determination is usually judgmental and subjective, and often based on trial and error. You're going to find one, and with the ability of Excel, we can develop many and choose the best one based on different a process we're going to learn at the end, where we can kind of evaluate the strength of the forecasting methods we've used. So let's look at this example. Demand for personal computers for one full year, January through December. We can look at this demand, and we can then use this to predict. So in this example, where you're going to use an exponential smoothing forecast, what we're going to use is a value of 0.3, and then we're going to use also a value of 0.5. We're going to develop two exponential smoothing forecasts. So the formulas there, we're going to work through these as we go through our example. So let's go back here. This is using the sales, computer sales here. We want to have basically an exponential with an alpha value of 0.3. Let's kind of go like this. and then an exponential smoothing method with a value of 0.5. Let's make that all the same. So generally, the formula, we're going to use the exponential smoothing method to predict what this method would have predicted for February. So the formula is the alpha value, 0.3, times the previous month's demand plus 1 minus alpha, which is 0.3, times the previous month's forecast, which in this case we're going to set the same to be 37. Because there's no previous month's forecast. Now to change our second one, and then we can copy this down, we're going to do the same thing, 0.3 times the previous month's demand plus 1 minus 0.3, we could probably just type in 0.7, times the previous month's forecast. So we would forecast for March 37.9. And then we can copy this one down. And let's get rid of some of the decimals there. Something like that. So we would predict in January to have 51.9 computer items demanded here. So in our exponential smoothing method, the first forecast we do in the second time period is always going to be the previous month's demand. So what we really should do, or need to do, is just the forecast method for that for the month of March in this case. So it's alpha 0.5 times the previous month's demand, which is 40, plus 1 minus 0.5 times the previous month's forecast, times 37. And this one forecasts 38.5. If we've set this up right, we can just copy this down. Let's all change that. One decimal place. We would then predict 53.6 computer items for the month of January. So in our next video, we're going to look at the process to determine which method is correct, because in both situations, the moving average ones, we calculated using the moving average, we calculated two different forecasts. With exponential smoothing, we calculated two different forecasts, those ones right there. Which one should we actually use? Well, it's going to be based on the strength, or how close the forecasting method was in the past to the actual demand. And that's what we'll look at in our next video.